Good afternoon, everybody. Liam, are you there?
Yes, I am.
Perfect. As they say, no dead air, right? No
Yeah.
silence on the air.
No, that's right. Yep.
So I guess with that, we are on the hour. Attendees are coming in. Somebody raised their hand. I guess that we will go through the housekeeping right now. So how about we start? We get through the start, and then as more attendees join, we should be able to start the webinar. Liam,
Yes.
take it away.
Okay, cool. So you can see the slides, yes?
Yes, that works just fine.
Okay, perfect. So welcome to the webinar. I'm Liam, and obviously you just heard Waldek. Just to go through some basic Q&A type things. For any questions that you need to ask during the session, please add them to the Q&A, not to the chat one. We'll be monitoring the Q&A. The chat one doesn't really work for us too well, so please add them to the Q&A. We'll try and pick up the questions either at the end or where possible throughout the webinar itself. The webinar will be recorded, and you'll be able to get a recording of it later if you have to drop off for whatever reason. But we like things to be interactive, so if you have questions, drop them in there. We'll do our best to answer them. We will schedule time at the end, but we'll do our best as much as we can. Okay, so where do we begin? Well, let's kind of give you some background of the reason for having these types of conversations and this type of webinar. It's not a normal type of webinar that you would kind of go into where we talk about things like this. So what I wanted to do is kind of just highlight some specific areas that will lead us kind of in this journey of where we're going to go. First off, I wanted to put 4 blocks on the screen for you. One's JavaScript, which I'm sure you're aware of, C#, C++, and then Python and Java. Now, these are actually the top programming languages that are used by hackers today. Notice that JavaScript makes it in there. So that kind of changes how we think about hackers working. You know, you have this idea, if you've seen some of those old movies where they're working on these green screen terminals, there's no colors, they're writing green text, because hackers always have green consoles for some reason. So they're typing in green text and it never looks like anything normal. But actually, in today's world, hackers just use the same coding that normal developers would use, but they use it for a different purpose than just, for example, in SharePoint, writing a web part or something else. So JavaScript is one of the top ones, and that's where we're going to focus a lot of our discussions today. But of course, C#, C++, Python, and Java. So if you want to become a hacker, those are your languages that you need to learn. So to go on top of this, Microsoft did some research recently where they looked at using their advanced threat protection. They looked at the top 10 most prevalent non-executable, so we're not talking about X's or MSIs, threat file types that they've seen coming through their cloud services, through email or whatever other mechanism, but gets picked up by advanced threat protection. And you can see instantly JavaScript is at the top again. So, and they classify it as a threat file type. So not just a script, not just a regular thing, it's a threat. So this is why we're starting to talk about JavaScript now and against SharePoint, because of course, SharePoint's changed over the past few years. If you think way back in the beginning, you didn't really customize it. Then we kind of moved into newer versions of SharePoint and we started writing full trust code, you know, C#, VB.NET, whatever it would be. And then we kind of transitioned to client-side code and then back to server-side code and then the add-in app model type thing and SharePoint Framework and client-side code. And so we're now back to this JavaScript world because it's the easiest way of customizing some of the user interface and actually making something lightweight that's going to work really, really well. Now, to give you some further background, JavaScript is the most common language that's used on websites. 93.6% of all websites in the world use JavaScript. That's including that SharePoint installation you've got on premises or that SharePoint implementation in the cloud. It's full of JavaScript. I mean, even if you look at the code under the covers that renders the ribbon bar, for example, lots of that is JavaScript based. Lots of data and security breaches are happening caused by using JavaScript. And the attacks are obviously becoming more sophisticated because JavaScript is not necessarily a simple language. It can do some very sophisticated and complex actions. So for example, if you're modifying the document object model in the website, you're calling a RESTful API, maybe you're calling some other component, the attacks are becoming sophisticated because they are injecting themselves into that space. So it makes it very hard to identify what's gone on because it looks like normal traffic. Now, a real world example of this almost in the past week or so has been the Ticketmaster breach. And there's a link there to the official statement that was made by the vendor that Ticketmaster uses. Now, an interesting thing about Ticketmaster is, of course, they're a large-scale website, global footprint, but actually the breach was caused by JavaScript. So I want to show you a specific response that was given by the vendor that they use. And this is an important lesson that I want to talk about today. Ticketmaster directly applied the script. So I put that in bold because this kind of how we work in SharePoint is the same principle to its payment page without notifying our team. Had we known that the customized script in bold was being used this way, we would have advised against it as it incurs greater risk for vulnerability. The attackers located, modified, and used this script to extract the payment information of Ticketmaster customers between February and June. So those bits in bold directly applied a script, customized the script, and then the script was used for malicious action of some description.
So Liam, just to check if I get that correctly. So in other words, in our world, there will be equivalent of putting a script on a page, like embedding it through the content editor or script editor web part and putting that directly on a page, right?
Correct. Yeah. I mean, that's the exact analogy right there is, and even down to the syntax, like the wording here that says they directly applied the script and the team didn't know. If you take a SharePoint environment, you as the IT admin, 9 times out of 10 don't actually know that somebody had put a script into a content editor web part or a script editor web part inside SharePoint. You would have no idea. And then of course the script is often customized by that person, or maybe they just took it from something online. And then of course the potential outcome is an attacker could have modified it and done something.
Right. So if I understand that correctly here, they had a link to an external script, and the attackers found that external link, that external script, and changed that because it was already included on the site. It would circumvent all security protection, all that, because it would already run as a part of that page, right?
Correct. That's right. Because once we reference something externally, obviously you have no control over what that external piece does. And so at that point, if I really wanted to, I could host an external file, a JavaScript one, specifically have you guys include it in a SharePoint site, knowing it does something silly, like maybe it changes the color of something, but 6 months down the line, I could change that to do whatever I wanted it to. And at that point, you would have no idea. And actually, it's already running as an authorized piece of code in the context of the user who's hitting the site in the first place. And you would have no idea what that code would be doing. So this brings me to the big word JavaScript. Now, don't get me wrong. Waldek likes to write in JavaScript. I like to write in JavaScript. I'm sure there's lots of people around the world that like to write in JavaScript. So I'm not saying that it's bad. However, just because of the way it works and the nature of how it renders in the browser and inside and connects to objects in the site, it makes it a very powerful and potentially dangerous kind of language. So what are some of the common attack methods that are used? Well, the first one is obviously we inject code directly. So that means I somehow have access to the site and I just inject the code into the site. So if we translate that to SharePoint, it would be the equivalent of maybe somebody adding it to a script editor or a content editor web part. So you're just injecting it directly into the site. The second option, which also can work on SharePoint, is this idea of ads and banners or images, where, I've worked on lots of public-facing websites that are built on SharePoint over the years, and lots of them do have ads and banners, and they're referencing external systems that provide those ads and banners or even images that come back. They could be infected with malicious JavaScript and do something that you wouldn't know. We also have the ability to inject into the data layer Now, this is a bit more complicated. So imagine this is kind of like a cross-site scripting attack or whatever else where, or injection attack, where I'm able to, the end user is asked to input information. I could input information, but I could actually import it in a format that would be JavaScript. So when it gets rendered back out, it actually executes JavaScript instead of doing that, because normally in those scenarios, the code that's been retrieved from the database and back in, or whatever the data layer would be, isn't checked and sanitized, and so it ends up executing. And then, of course, we have remote file framework loading. Now, this is really, really common. I can guarantee you every single SharePoint environment that I've ever looked at over the years loads at least one external framework. It'll be jQuery, it'll be some external library that does something magical, but basically branched off jQuery, or something on GitHub, or something that used to be on Codeplex or whatever else. I mean, I use the example that I've used in the past, not to do with JavaScript, but years ago, I wrote a web part, the claims viewer web part. I must admit, it was a fantastic web part, if I say so myself. It lets me put it on a page. I can hear Waldek laughing now, but I put it on a page and it just rendered the claims of the end user coming in. I made it publicly available to everybody. And then over the next couple of years, as I went and looked at various SharePoint implementations all over the world, it was surprising to see that that web part was just installed in a production environment.
Absolutely, and yeah, and I guess that's surprising thing about that is that was a binary, right? That was not a script.
Correct.
It wasn't easy to review what's inside that code.
Correct.
Right?
Yeah, because it was basically a DLL, and there was no way of opening that back out unless you can reverse engineer it. But it was, I mean, that to me was even worse, because it's a DLL and everybody trusted, hello, it's Liam, claims viewer web part, just because it was given by me. I mean, but I could have put something in there that called home. I could have put an external link to something else. I could have wrote malicious code, but obviously I didn't. But then the question would be, well, did you check that code? And of course the answer is, well, no, I just got it from your site and I put it on the production environment. And so that raised a few questions. More so now, because JavaScript allows you as the website creator to run any code that you want when a user visits that website. Realistically, any code. Obviously, based on authentication processes and tokens for OAuth, for example, determines what permissions you actually have. But effectively, as soon as a page loads and I go to access it, I can have JavaScript do something that the user wouldn't know about. And that's the issue. So there are 5 stages to a JavaScript attack. And so I wanted to kind of talk these through. The first one is the entry point. So if we map this to SharePoint, because that's what we're talking about, so SharePoint Online, for example, the entry point is going to be either the external reference or the snippet of code that we've taken. So maybe Waldek releases a piece of code and says, hey, this code's fantastic, let's get it. And you can put it on your site and it shows the time of the day, just because people want to see that. So you take the code that Waldek's given you and you plonk that directly in there. So that's your entry point. The distribution of that could be that you perform some kind of page redirect, or there's something else that it does in the background that downloads something. So one of the things, for example, I do a lot with PowerShell is you can use an invoke command inside PowerShell to actually download something into memory so it never hits the disk, and you can execute those PowerShell commands without it being on the disk. And so then it's harder to find what's been going on. Now, of course, in JavaScript, we could do the same. We could have it so we temporarily download a JavaScript file from somewhere else or something else. Maybe it's, an exploited file, and then that becomes that distribution method. The exploit could be something that's commercially available. It could force someone to do a specific download. It could be something else. And an exploit is a vulnerability of something in the system. After that, it's all about infection. So for example, we're going to do something and it's going to infect the SharePoint environment. Now, I know it sounds kind of weird that you would infect the SharePoint environment. So that's the official word. But realistically, what we're talking about is it's going to do something that it wasn't meant to do. So maybe it's going to delete some content. Maybe it's going to start adding content. Maybe it's going to start encrypting content. Maybe it's that famous one that Waldek had talked about previously, where it's going to start doing Bitcoin mining and make you loads and loads of Bitcoins, but something that it shouldn't do. And then lastly, you have execution. This is when it does the thing that you don't want it to do, where it's going to actually say, I'm going to call home. I'm going to start sending data externally. So for example, if you look in the Microsoft Office 365 site and you look at Secure Score kind of groups everything by specific terminology. And so execution would potentially be things like data exfiltration. So streaming the data somewhere else, or maybe data spillage or something else. Or maybe it's trying to do something even more nefarious than that. So these are kind of the 5 stages of an attack that would take place. And it all stems from you adding a snippet of JavaScript to a page. And it sounds silly, but realistically, that's what it could be. I mean, I can send you, and Waldek can attest to this, because I tried to send him a piece of JavaScript and have him execute it, and he wouldn't.
Oh,
But
no.
yeah, but
it's like the rule number 1: never trust any code coming from Liam.
but I did promise and say that there was nothing wrong with it, and my promise.
And they all do. And they all do, right?
Yeah, that's right. That's right. But that's the key. It's like, I've got some code. I put it on GitHub, let's say. I've wrote a little README document that says, hey, it's fantastic. This is what it will do. It's not going to harm anything. You look at it and say, of course I'll take the code. You paste it straight in. At that point, it becomes a potential threat, unless you've gone through and checked and done different things. So I suppose the big question, can SharePoint protect from these types of attacks? I mean, realistically, okay, so think about it. You've got on-premises SharePoint, or you've got Office 365, and you've got SharePoint Online. On-premises, you just install it. It's down to you to protect that. There's no magic button that says, you go into Central Admin and it just says, protect SharePoint, yes or no. And you say,
on.
Yeah, on, that's right, yes. On, protect SharePoint. I mean, really, that button would basically deny access to everybody. That would be the only way of protecting SharePoint, But SharePoint Online, there's a bit more there. We've got technology in the background for machine learning and, advanced threat protections and everything else. But does it really protect from these types of attacks? Well, I suppose another question to this would be, well, is it really an attack? Because actually, you put it there. So you're not attacking the SharePoint environment. You actually just put that there in the first place. So the first thing to remember is SharePoint has no protection capabilities. I mean, it doesn't. I mean, it has some bits and pieces that we'll talk about in a bit, but it doesn't really have any protection capabilities that would stop you from putting a script editor on a web page and pasting in somebody else's script. It doesn't look at the code. It doesn't check anything. It will basically just execute whatever you put in there. The SharePoint footprint is massive, whether you're on premises. So at least on premises, it's ring fenced just to SharePoint. But in Office 365, I can have that code run a whole host of other things. So I could call the Graph API, for example, which then gives me access to other services. So the SharePoint footprint, or it should really say the Office 365 footprint, because that's what you can get access to, is massive. And second, JavaScript is now the language of choice. That's the way that we should be building solutions. You can include external libraries and references very easily. RESTful APIs expose nearly all the data that you could ever want from SharePoint, especially if you're using the Graph API, for example. I can go in and basically get everything that Waldek's ever done based on the permissions that I have access to. And if I'm running it in a certain way, I could get access as him. Permissions are defined at deployment or as the current user, depending on how you're building the solution. If it's just a power user adding a script to the page, then of course it just runs in the context of the user. Maybe if you're doing deployment and it's something like a SharePoint Framework one, then maybe we're using OAuth mechanism, the whole consent framework to assign the permissions to that one.
So, isn't there? So imagine that maybe the portal itself can do that. But what if you have, for example, a firewall, right? And you
Okay.
mentioned a few times that you would have a script on a page, and that would try to call out to an API, call back home. Wouldn't a firewall, because that's a thing that I've heard a few times, that people say, like, I have a firewall, so I cannot be harmed by that because firewall will hold all of that back. Is that true? Is there any truth to that point, or is it incorrect?
So it's one of those things where initially, if someone says, okay, so let's work through the scenario. I have a SharePoint site. Let's say it's online. I go to the SharePoint online site. I add a script editor web part to the page, and I put some JavaScript in, and the JavaScript calls out to an external JavaScript file, either as a reference or it's calling some kind of function from a CDN, for example.
Mm-hmm.
There's no way of stopping that. Just because you have a firewall, unless you've blocked internet access for the SharePoint environment in Office 365 and no other workstations can get to the internet, then no, it's always going to work, because port 80 and port 443, so HTTP and HTTPS, are always available because those are common standard ports. So unless your reference is referencing a URL on a funny port, for example, I have seen it where you're referencing something like 8443 as a port
Right.
to get something, then yes, the firewall can block that. Now, if you have an advanced firewall that does, for example, content inspection, which is much more complicated, then you could. Now, the only way this would work is you would have to work with the IT team directly to be able to say, well, I've put this script on a page and it calls this URL. You would then have to take that URL, look at the response that you get back, put that into the firewall that does the content inspection, and then validate what the response would be. Now, that's not a small task. So a real world example of this, I did this about a year ago with a client of mine, where we had an API that was being called. It returned XML data, but the XML data had to come back in a specific format. And because this company was a security firm, they wanted to make sure that it was always the same format. So that's what we used. We used a content inspection platform to validate that the XML matched the format coming back. But that was no small feat. That took a lot of testing and a lot of checks to get that right.
Right, but that's exactly the point, right? Because why people put scripts on pages? Because they want to be agile. They don't want to wait for approval, consent. They don't want to go through 3 months approval time, a review time for every piece of script that they need, right? If they need a widget, they want to be able to do it by themselves. And in a way, they are empowered, right? Because the platform, SharePoint, allows them to do that. It allows them to add a web part on the page. And if they have permissions to do that, they can do that by themselves. They don't need anybody's permission to do that because they already have everything that they need, except with the fact that they can then cause all kinds of risk that you just talked about.
Yes, that's right. And that is kind of the quandary that you find yourself in when you're working with SharePoint specifically. Is, it's the same thing as permissions in general. Microsoft came back and said, you want to delegate owner access and permission control to the end users. And so everyone starts doing that. They go in and say, well, I'm IT. I'm going to make you the power user over the finance department. You can do all the permissions. And then in 6 months' time, you come back and look at it, and no one seems to know who has access to what. And everybody has access to everything. So it's that same principle when it comes to things like this. You want to empower the end users to do what they want to do. But by doing so, if there's no checks and balances, then these are the kind of issues that you're going to get. And of course, Microsoft then go one step further and they say, well, hey, why don't we use this new way of doing it? Because of course, we like to change the ways that we code. And so let's bring in SharePoint Framework. I happen to like SharePoint Framework. Yeah. I think it's fantastic.
Maybe before we switch, there is a question that we got regarding to what you just said about the constant inspection techniques. So how much performance hit would that be if you were to implement that in SharePoint?
So if you were to implement a content inspection
on, or actually on network,
on everything that kind of went backwards and forwards, it wouldn't be significant, but it would really be down to what you were trying to validate. So in that real world example where I was validating XML, it was actually fairly quick because as the retrieval of the XML came back, we knew where it was coming from, and it was a quick kind of regex pattern match all the way through, and it would pass or fail. But if you're trying to validate JavaScript and make sure it's coming from where it's coming, that's much more complicated. I mean, think of the logic. What is it you're going to check?
Exactly.
So are you checking the files come from the right place, or are you somehow going to iterate the code to make sure it matched what it was supposed to match in the first place? If it's that becomes much more complicated. And then what happens if someone does something to the code and you don't know? So there is a potential performance impact just because of the lag it takes. And of course, if you're in Office 365, SharePoint Online, that's a whole other complicated story, because you don't have a content inspection device that you own sitting up there. So you're having to do the checks on your environment, but going out to the cloud to connect, to come back to check before the end user gets the request. So it changes the flow and it becomes much more complicated.
And I guess the impact from that would be bigger on the side of the review process and approval than technology and network, I guess.
Yes, that's right. Yep.
All right. SharePoint Framework.
Yes.
Is it better?
Yes and yes.
Don't start with it. It depends.
Yes, yeah, we'll do the consultant answer. It depends.
No.
SharePoint Framework is better, and I'm going to give you 3 reasons why. Only 3. So creation and deployment, much better. Centralized control deployment, better code management. You know, you're using VS Code or whatever else. It can go into GitHub or TFS or whatever else you want to use. And then basic code validation. And what I mean by code validation, it's not going to say that your code is going to do exactly what you said it's going to do, but using things like the linters, so TSLint, JSLint, and anything else you get from there, you can do basic code validation. It'll check some of the things that you would have written. If you've wrote something that, you know, is using, for example, JavaScript eval, which we all know has been a bad thing for a while, then it will flag that and say, hey, did you know that this could be used maliciously? It doesn't tell you to change it. It just offers you a suggestion, and then you could decide what to do. But that's still good though, because 9 times out of 10, when we write code or we take code from someone else and we just paste it out there, we don't do any of that. We don't check the code. We don't validate the code. It just gets done. And if we have internal developers, unless you have a process in place to validate all of the code, you just accept that the dev wrote the code and it's good to go. Especially if you can see it working, then no one seems to worry about checking it. So SharePoint Framework is better. I do like it. It uses industry standards. It uses standard Webpack technology and a whole bunch of other things together, which does make this much easier and actually a little bit safer to use. Plus, when it's deployed, it's a controlled deployment. There's various permissions around the deployment, and also it utilizes the elements of the consent framework and the permissions that you decide to assign there. So it's much better than just plonking a script on a page. So that's why I like it. It's much more controlled in that sense. Now I'm going to give you the 3 no's. So does it block malicious code? Nope. Does it identify malicious code? No, not really. And does it validate and protect external references? No. So for me, those are 3 big things.
Right. So is there anything else in SharePoint that does that, or is it just a no across the board?
It's a no across the board, and it always has been. Even, I mean, let's go back to managed code. If you're writing C# code, is it going to block malicious code? No. Is it going to identify it? Probably not. Is it going to validate and protect? No. So you have the same problem whether you're doing old school C# managed code or using client side and moving to SharePoint Framework, SharePoint add-in, or whether you're writing a script that just goes in a page. So this isn't a fundamental dig at SharePoint Framework, because SharePoint Framework quite clearly has 3 things that are much better than any other mechanism. But it doesn't help us identify and protect when we have those certain kinds of things, malicious code, obfuscated code, or whatever else. It doesn't know what to do with that. So the big question is, how bad can it really be?
It can be bad. I guess well, so how about we do it that way? We show you in practice how bad it could be, or what could be one of the things that it could do, and then we leave it up to you to judge whether you find it bad or not. Okay?
Perfect.
Cool. Let me share my screen and show you a little thing that I've built. All right, so here I am in SharePoint. That's a classic team site, and I want to enrich that. I want to embed a widget on that that will show the weather. That's just a simple thing that many intranets have, and it's just a thing that people understand. So I did some search on the web, and I found on GitHub this project from this guy. That guy, he's an MVP. It says here, so he has to create proper code, right? So here it says the weather widget you will ever need. Perfect. It allows me to show the weather in any location in the world, Fahrenheit, Celsius, no installation required. Basically, 3 things that I need. So yes, yes, yes. Minimal path to awesome. Put this in SharePoint. Brilliant. That's simple. So let me just grab that, copy paste that, edit the page. I will put on the page a script editor web part, or actually embed script, embed code. Let me put it here. Insert this HTML will be inserted in a web part. Perfect. Insert that. And it works. And we have sunny weather in Seattle, Washington. Perfect. Right. So we could even adjust that, but at this point it works just fine. So with that, my work is done. I didn't need any approval review because the code just works. There can be nothing wrong with that. Right? Now imagine that person who created the widget or somebody else, right? Because there are some external scripts that are included as well, which change something about the script. So imagine now there's either malicious PR, malicious change to the code, or somebody says, let's change that. So in here, being owner of this code, I can edit that, and let me just extend that with a piece of code that I prepared up front, which is this. And you will have no idea what it does. You might look long and short, and it wouldn't be easy for you to figure out what it does. So let me just paste it here at the end. And with that, I will say I fixed a bug. Because there was a bug, I fixed that. And you could even say something like improve performance, added some additional options, added new icons, right? And that will be just fine. So with that, we didn't change anything. Don't look at that. I added the warning there so that you will not run that in SharePoint, and you will see exactly why. So imagine the next day, people come to the intranet and they just use that, and everything seems fine, right? The thing just works. Now imagine the person who owns the script. So this is now on the right hand side. You see the email of the person who owns the script. And if all is well, we should be seeing some action in a moment in there. And let me just quickly check that it's that the cache from CDN is not preventing us from doing things. It's cached. Let's do a quick fix, because sometimes when you add that, it will cache the script for a while, so you won't see it directly in browser. But you could assume that at some point the browser will be the cache will be cleared. But for now, let's just force that by appending change to the URL, just to ensure that we pull in new version of the script. jQuery, let me refresh the page. And why isn't it working? It's always like that in a demo. It should be working. It's still pulling the, if I go here to the script, it's still pulling the old version of the script. Let me just double check that I committed that. I went to here. This seems to be the, yeah, so this is updated version of the script. I disabled the cache. Is there anything else that I can do to force that other than wait? No. Oh, that's unfortunate. It used to work. I checked that like 5 times today and it just works, and now during the demo it doesn't, of all times. It's always like that.
It's always the way, always the way.
It's always the way. Is there anything else that I could do to show it? I might, can I rename the file through here directly?
I mean, technically, you might be able to take the JavaScript, paste it in the console, so it overwrites the methods.
Let me just add here, simple weather 1.
Okay.
Submit, commit changes, changed file name. Let's do that. So as you can see, being a hacker is not an easy thing, right? And you need to really appreciate these folks. It takes some job to get it done. So here, let me change this one. Let me insert that. Okay. And we still have our snippet. It still works. Now, let's see if we will be calling jQuery. There you go. All right. There is some action, there is some email, and now you can see that every single time, so let me close that one, let me refresh the page. And now what you see here is every single time somebody comes to the page, a piece of script runs, and somebody else receives a document. And if I increase it a bit, you can see that the person gets via email confidential docs. Right, so every single time that page will load, the malicious script, what it does is it uses SharePoint search to find confidential docs, and every single time it picks a random one and sends it over to this email address. And the only thing that you can see the way that that's being done is that there's additional call to change a query, and that's a post call. Right, so there is some blob attached to the v argument, and here in the post we send some stuff as well. So that's the only, if you really knew what to look for, you would see it, but otherwise you would just not see it at all, right? Because nothing about the script visually changed. It still works. Right, so, and that allows you to do really malicious things, because if you think about it, imagine that the person on the page is the tenant admin or CEO or even the HR manager. I mean, these people have access to confidential things. They can do things that regular users cannot. And that script will run as that user, meaning whatever the user can do, the script can do as well, which gives you really powerful things that a script can do. And as long as it can call out to an external API, it can send emails, it can send off the data, it can do anything. Right? So with that, I guess the question is, what can you do about it?
I mean, in reality, what would you do about it? I mean, it looks like valid code, and that's the argument, isn't it? It's completely valid code that works as expected. And of course, the only reason that it becomes a threat is, one, obviously you added something malicious in the background, but the only reason it's a threat is based on what it does and sending the information. So you said something interesting before you did this. You said, well, let's show and see whether you think it's a problem. So it would be interesting to know from those that are on the webinar if they think this is a problem.
Yeah, to have a quick chat thing of 1 problem, 0 not an issue.
Yeah.
Like, type 1 enter, 0 enter, and then we will do a count afterwards. Meanwhile, one trick, and that's actually a funny thing, right? Because for this particular case, like imagine you reference an external script and you want to protect yourself from an unwilling change to it. There's an easy trick that you can apply, and that works in most browsers that we use nowadays, right? So in here, when we edit the page, what you can see is that we added, let me just change that. So here we had the original piece of code that we added on the page, right? And in here, that's actually the whole trick, right? Because the script isn't there. All of that is coming from external URLs. And there's a great feature available in browsers that allows you to ensure that if the content of the script would change, the browser itself will not allow that script to run. And that's called the sub-resource integrity. So imagine if I take the other example, which I have here, and the code part is exactly the same, except for the two things here. So in here, where I have a reference to the script, I add two attributes. I add integrity hash and origin, right? And I need to include the origin for the browser to be able to verify the hash. But the key point is this hash. So this hash says that if the contents of this script do not match this hash, do not run it. It's so simple. So if I now paste that code, let me just swap the first two lines to here, and you know that we changed the original code. And I'm not sure if the cache is already working. If it's not, we can always change it to the 1 because the file name doesn't matter to that. All right, and now we already see that the widget doesn't run. And if we refresh the page, we will see in console some errors. There it goes. MIME time is not. Oh yeah, MIME time not executable because we renamed the file. Let me change its name quickly, because that way it won't work. So in here we need to change to, where was it? Simple weather 1. Insert. Okay. And if all is well, it will still not work, but it will now fail with a clear thing. Yeah. So here, this is important part. Find to fail, or find a valid digest in the integrity attributes. In other words, somebody changed the contents of a script and it no longer matches the hash that we included originally. Right? So this is a really trivial way for everybody. Whenever you include external script, have a look at that if it's sound. If it is, create for it a hash. And there are a few sites on the web that allow you to give a URL, and they will create for you this hash. And then just add that hash every single time you have a script tag, because that will allow you to ensure that if somebody would change that script, you will not blindly run it with any edit code. I guess it's we have one more slide that we wanted to go to talk about some other things, and then we will show some more stuff. Liam, you want to share your screen?
Yep, I just have one question as well. So a question was asked. So what identity was the SharePoint search performed as that retrieved the confidential documents?
Right. So this is a part. So this is JavaScript that runs in browser as a part of the page. So at that, it runs on behalf of the user who is on the page. If that's an admin, that search query will run as admin. If that's CEO, that query will run as CEO. So in this scenario, the script is a part of the page, and it can do whatever the user who is visiting the page is allowed to do.
So the key is to always redirect to the IT admins or the CEO whenever you put malicious code in SharePoint?
Well, one trick that we talked about a few times is that imagine you create a web part, and the web part checks, is the user currently on the page an admin? Yes or no? If no, show error. And a part of the error could be contact the admin, or tell admin to go, or give admin this link. And the admin will come to this page, and they will see either an error or everything will be fine. But at that point, admin is already on a page, and the script already runs as admin.
See, now you're giving away my secret. That was my secret way of doing it.
Oh, so that is the error that I've seen the other day.
Yeah, that's right. The error that you got the other day was purely just that.
Never trust Liam. Never trust Liam.
Yeah, that's right. Okay, so let me just share my screen back to the slides.
Yep.
And so we're back to how bad can it be?
Yep.
So the question was what can be done now to protect from things like this? So the first thing is block content editor web part use. Now, I've also put block script editor web part use, and there was actually a question that came up which I answered earlier. And so that's really a business decision. That's entirely up to you. Blocking them completely kind of removes the capability and doesn't empower the end users. However, it definitely is a way of fixing it. So block script editor, block content editor from being used. The third one really is the most important one for me, is review all the code. So put a process in place to allow you to review code. Do not deploy until after it's been checked and approved. which is a step that seems to be missing. At least these two steps I tend to find don't get done. Validate all external references, and also obviously go along with what Waldek was talking about just now, where we can do some kind of simple browser validation of those two. Convert the customizations to SharePoint Framework, and I'm talking about classic customizations where you're just putting scripts on a page. Well, let's take the time, convert them to SharePoint Framework, so they have to go through a process of validation and deployment. And then utilize the no script option within the sites to kind of control where those scripts can actually be put on a page. So those are kind of the things that you can do right now. And it doesn't look like a lot, but actually if you start to implement some of these, this will help in protecting and controlling what that code actually does. So I suppose the next question, how could we help you? How can Rencore help?
Yeah.
Because obviously this is the purpose of the webinar. We're talking to you about the kind of risks. We can tell you the things that SharePoint can do. We tell you the things that SharePoint doesn't do. So are there things that Rencore can help you with?
Sure. Let me share my screen so that we can show some more things. So as Liam said, one of the things that you should do is you should always verify the code that you are about to run in production. But it's hard. Like imagine this. This is a block of minified code, and I wish you luck going through all of that and checking that it doesn't do anything that it's not supposed to do, like the example that we've just seen with a simple call to search and then call to external API, right? That could be anywhere in this code, and this is just single script. Imagine doing all these checks across the whole internet when you have dozens or maybe even 100 of web parts and scripts and widgets, and that nobody really keeps track of that, right? And even if you had just one, it's still a tedious job to have a look into that, right? So what we offer you is a solution called SPCAF. SPCAF is a tool that allows you to run analysis on whatever you have built, whether that's single script or master page or display template or add-in, WSP, or even packages in SPFX, to verify that against over 1,000 rules that we created over time that check from everything from performance to best practices, security, disposal checks, and so forth and so on. If you have single file, you could validate that by yourself, right? So if you look at the widget that I had, you could just go through that. That seems fine, except for these two things, because these are external scripts. So you could really easily run this check. But the moment you get significant code base, that analysis will become hard. And this is exactly where you can use SPCAF, where it will help you. And you can use SPCAF in a number of ways. If you develop code yourself, you could use it directly there in VS or VS Code. You can integrate it with your build. You can even integrate it in your PowerShell scripts that you use to actually deploy the packages to production. So SPCAF could be a part of that step where you run analysis. If there are any errors, you don't deploy, otherwise you do. And in here, I have a Windows client app that you can use as well. So imagine being an architect or a person on the team that doesn't develop but does, for example, Q&A or QA, right? So with that, you could use this app to analyze it. So in here, you can just drag and drop a file that you've built, whether that's a HTML, SPP, PKG, and that will start analysis. But not to waste time on that, let's have a look quickly at a report that I analyzed earlier today, and that shows exactly a few of the issues that Liam and I talked about today. So after you run analysis, you will get an overview, and the interesting part for us is the quality assessment. So we go into here, and in here we have an overview, and we are interested particularly in any issues. And one of the things that we talked about is the importance of including integrity hash. And look here, SPCAF will exactly warn you about it, and not only tell you that in this case we didn't include integrity hash, but will also explain you why it's important. More than that, it will also pinpoint the exact line in code where you should do that. So with that, you don't only get the issue, but you get also the guidance and exact location in code where you should add the hash. But actually, it found out an even important issue. So it turns out that jQuery that we use has a known issue, and it says vulnerability found in index.html library jQuery version 2.1. And to actually remediate that, it tells us to update to at least version 3.0, and that's being located here. So apparently, next to the integrity hash, the widget that we've built originally ships with a vulnerability that a hacker could use to exploit the script even more and maybe even inject some more code, right? So there are quite a few things that you will find in SPCAF that allows you to ensure that whatever you put in production is sound. And if you think about it, like a file, you can browse directly into that. But imagine you have a package like here, like SPPKG that you get in the framework. So in here, you now get XML files and folders, and in order to see what's in them, you have to just browse one by one and explore the contents. And if you look at that one, well, there is embedded JSON in XML, and that's getting more and more hard to read. So again, for the same thing, you can just drag and drop the package, or even if it was WSP or add-in with an assembly and a DLL, SPCAF would analyze that too. And similarly, you will get the same reports with quality assessment, analysis score, and also showing you what is wrong and what needs adjustment. And another important thing that we get here, for example, in SPFX, is that you should only load web parts and external scripts from URLs you approve. Because if you would, like me, originally in the demo that I showed, like you will load script from a URL you don't own, somebody else can change the file and you would not even know about it, right? So this is why it's important, for example, for SPFX, but also for widgets that you just embed in pages. Always think about which URLs you allow, which you don't. And in SPFX, you actually get, as admin or as QA person, you get the ability to verify all of that up front, because SPFX packages are deployed always through catalog. Whereas if you allow embedding scripts on pages, well, that's game done, right? So for that, we offer another solution about which you can read more on Rencore.com. So I guess that we are closing into the hour. I guess that it's time for us to switch back to the slide, go through a few more things, and then open up for Q&A. Liam, you want to share slides again?
Yes, indeed. Okay.
Perfect.
So how can we avoid security risks in SharePoint then? I'll give you just two top options for now, and then Waldek can talk through the rest. The first one is to define a code review process. That's number one. I mean, if you do a fully fledged code review process, whether it's a manual or ideally using something like SPCAF, then of course that's going to help you to test and validate all of the code. And that's the key. The key is you're not trying to stop the code going there. You're trying to just double check and make sure that the code should be allowed to run. Because if you stop code completely and stop making changes, then often what you find is nobody wants to use the platform because it doesn't quite do exactly what you want to do. So there has to be this kind of balance that you go with. So Waldek.
Yes, so as we said, right, you can try and go through all of the code manually, but it's tedious, inconvenient, and you will quickly find that it will not work, because eventually you will find code that is minified, or you will find DLLs, packages, and you will just not be able or to have the bandwidth to run that analysis every single time, because just because somebody said that they change only that one thing doesn't mean that that's actually the case. So at the end of the day, what you want to do is every single time you are about to put something in production, to review consistently in repeatable way that whatever you are about to run in production is sound. And SPCAF is a perfect fit for that because it simplifies the analysis, right? It allows you to decrease the amount of time from hours, maybe even days or weeks, depending on the size of the things you want to analyze, to minutes, right? And it gives you also the ability, it has over 1,000 rules, which is a lot of things to keep in mind by yourself every single time you go through code. So that's for the pre-production stage, right? SPCAF is when you build code or you have built the code and you have a package. If you allow embedding scripts inside a tenant, we have another product called Analysis Cloud. And what that does is that it live monitors your tenant, meaning all scripts, pages, everything that users can customize and adjust. And if there is anything that is against your policies, it flags that, alerts you, and allows you to immediately take action on it. The cool thing is that Analysis Cloud also integrates SPCAF in it. So when you deploy package to production, it will also analyze that. Why, you might ask, right? Because you've already analyzed that before deploying to production. There are two reasons. First of all, oftentimes libraries that you use are being patched, security fixed. So even though you didn't change your code, how would you know that jQuery 221 should now, or that it's now recommended to use jQuery 222 because there was security fix to it? It's hard to keep track of all the different libraries that you use across your whole intranet. So Analysis Cloud does that for you, and using the SPCAF engine, it will analyze the code, the packages, and tell you that package right there is old, update that. Another thing is that you've seen is apparently in the package that I had a known vulnerability. And that was also in jQuery 2.1, and it was recommended to update to 3.0. Again, if you didn't change your code, it might not get, again, through the pre-production stage with an automated build. You might just leave it there in production because it works just fine. But if there is recommendation to update that because there's a known issue, you will not know it unless you actively keep track of that. And this is exactly what Analysis Cloud does for you. So with that, if you want to know more, I would encourage you to go to the link that you see on the screen, and you will get the slide, you will get the link to go there, read more, and actually give SPCAF a try. It doesn't cost you anything, and it will help you understand the issues that you are exposed to when you build solutions on SharePoint. So with that, we have 3 minutes left. How about we take a few questions, Liam?
Yes, indeed. So the first couple of questions are targeted for SPCAF. So when I do a gulp build, it would be nice to have the SPCAF stuff run, perhaps as a VS Code extension.
Yes, so we already do that. So already a while back, I think the moment that we released support for SPFX analysis, we have a Yeoman generator that allows you to hook up SPCAF with the gulp task that you have in SPFX. And at that point, you can just run gulp SPCAF, and it will run exactly the same analysis as if you would run on project. You would just drag and drop the folder on the Windows app, so you can just run all of that directly from gulp. That's already in place.
Perfect. Then also, did they hear correctly that that the SPCAF can deploy the SPFX package to the app catalog, maybe?
So SPCAF wouldn't do it, but what you would do is imagine you have CI/CD pipe, right? So every single time you commit code, you push that. On that, you run build. A part of that build is SPCAF analysis, and you can hook it up even to a release in VSTS. So you could have a gated release when it takes place only if SPCAF analysis didn't find any issues or any critical issues, right? So you could say compile code, build package, analyze with SPCAF, and then if no issues, deploy. Otherwise, flag and warn the team.
Perfect. And then we'll do one more. What type of code reviews are performed in the PnP open source packages?
In the PnP open source package, well, that depends a lot on the coordinator of each repo. You can think of it as, while there is PnP team behind it, each repo is coordinated by their own team, and that team decides basically what do they validate and how. So if you have specific question about specific repo, it would be the best to ask that in that repo.
Okay, perfect. We'll get to the other questions and we'll put a response out a little bit later on. But thank you, Waldek, for a great demo.
And thank you very much.
Hey, anytime. And obviously, last but not least, our next one coming up will be 10 reasons why you should move away from InfoPath now with the all famous Erwin and Addis. So look forward to that. That'll be July the 25th. Is that right, Waldek?
I believe so.
Okay, perfect. So look for information on that one. And just a big thank you from me and from Waldek for attending. The webinar recording will be available to you later today. So thank you for that. If you have any other questions, feel free to reach out to us. And of course, we will post more information about these types of issues. And of course, as Waldek said, go to the Rencore site, go and get a trial, go and play, and then by all means, reach out to us. We're both on Twitter, so feel free to reach out to us at any point. But thank you.
Thanks, guys. Bye.
Bye.